In this session, we learn convolution. So convolution can be carried in analog domain as well as discrete domain. In first, we are going to understand convolution in analog domain. So convolution is a process of generating a third wave by overlapping two waves. So let us consider two signals x of t and h of t as step signals applied to a system. So the convolution integral is given by y of t is equal to convolution of x of t and h of t, where this star marks indicates convolution operation is happening. So in integral form it is written minus infinity to infinity x of tau h of t minus tau d tau. So when we analyze this expression, it indicates that convoluted output y of t involves in 4 steps. The first one is changing time t to tau base, and then we have to flip and time shift h of t. Then we have to multiply both on overlapping, then we have to sum. So for this given statement problem, x of t and h of t, which are unit step defined by this equation, is represented in waveform as shown. U of t means unit step, where it is having unit amplitude for t greater than equal to 0. For t less than 0, it is having 0 amplitude. So this system shows the presence of input, output, and a system with system response. So now, in order to carry out the convolution process, write the waveforms for x of t and h of t as shown. The axis here is time. In the second step, we are going to change the variable t to tau by retaining the amplitude of x of t and h of t as it is. In the third step, by retaining first signal as it is, we are going to flip the second signal for t is equal to 0. Now we are going to push head, that is the time shifted signal h of minus tau, to left side of this axis. So now we are going to analyze the condition for t less than 0, that is this portion. For t less than 0, is there any overlapping on moving this waveform from left to right? So for t is less than 0, there is no overlapping of these two waves, therefore y of t is 0. Now we are going to see the next condition for positive value of t, for t greater than equal to 0. As I move the waveform towards right hand side, some portion of x of tau overlap with the response of the system, generating the third signal as shown. So now from this figure, it is clear that from 0 to t on tau axis, 0 to t on tau axis, two signals are overlapping here. Therefore, we can write the integral expression from integral from 0 to t 1 into 1 dt or d tau, that is equal to t here. So what is y of t is equal to t represent? Y of t is equal to t represent a ramp signal. So in summary, if the input is step signal and response of the system is step, then the output will be a ramp signal here. This is the fundamentals of the convolution process.